Caves have always held a unique place in the human imagination and in the scientific study of our deep past. Unlike open archaeological sites, exposed for millennia to weather, erosion, animal activity, and human disturbance, a cave, sealed off from the outside world, can act almost like a time capsule, preserving whatever lies within it in a state remarkably close to how it was left, sometimes for tens of thousands of years. This is exactly the kind of discovery that has periodically emerged from deep cave systems around the world, and one particular case, involving a chamber sealed by a natural rockfall or mineral deposit roughly 30,000 years ago, has become one of the more remarkable examples of exactly why these sealed environments matter so much to archaeologists and paleontologists alike. To understand why a sealed cave discovery like this generates so much scientific excitement, you first need to understand what typically happens to organic material, bones, tools, artwork, over the vast timescales involved in prehistoric archaeology. In most open-air or partially exposed sites, oxygen exposure, fluctuating temperatures, water infiltration, and the activity of scavenging animals and later human populations all combine to degrade, scatter, and destroy the vast majority of physical evidence from ancient human and animal activity relatively quickly in geological terms. Bones decay, wood and fiber rot away entirely, and any organized layout of tools or remains becomes scrambled long before modern archaeologists ever arrive to study it. Caves that become naturally sealed, whether through a rockfall blocking the only entrance, gradual mineral deposition sealing a passage with flowstone eye, or shifting geology closing off access entirely, effectively halt this degradation process, creating stable, often cool and low oxygen conditions that can preserve organic material, footprints, charcoal from ancient fires, and even delicate cave art in a condition far closer to its original state than almost anything found through conventional excavation elsewhere. Cases like this have precedent in the history of archaeology, and understanding those precedents helps put newer discoveries into proper context. The most famous example remains the Chauvet Cave in southern France, discovered in 1994 after being sealed by a rockfall roughly 21,000 years ago. When French cave explorers first entered Chauvet, they found charcoal drawings, primarily of horses, lions, rhinoceroses, and other Ice Age megafauna, so remarkably well preserved and artistically sophisticated that initial carbon dating results were met with genuine skepticism within parts of the archaeological community, since the artwork's quality and technique seemed almost too advanced for what many researchers had previously assumed represented the earliest stages of human artistic development. Subsequent, more extensive radiocarbon dating eventually confirmed the initial results, definitively establishing Chauvet's paintings as among the oldest confirmed representational artwork created by humans anywhere in the world, forcing a genuine reassessment of how early and how quickly sophisticated artistic capability actually developed within prehistoric human populations. More recent, sealed cave discoveries have continued to build on this pattern of forcing scientific reassessment. In various karst cave systems across Europe and Asia, sealed chambers discovered in the past 2 decades have periodically revealed similarly unexpected findings. Articulated animal skeletons preserved in anatomical position rather than scattered as decay typically produces, ancient footprint trails preserved in cave floor sediment showing details of gait and even, in rare cases, evidence suggesting group movement patterns of early human or hominid populations moving through the cave system, and in several notable instances, evidence of controlled fire use and tool deposition patterns, suggesting these caves served specific ritual or symbolic purposes rather than purely practical shelter, based on the deliberate, non-random arrangement of certain objects and remains found within them. When researchers investigating a cave system sealed for approximately 30,000 years gained access, following careful geological assessment to confirm the seal had genuinely remained undisturbed since its formation, initial surveys revealed exactly the kind of remarkably preserved conditions that make sealed cave sites so scientifically valuable. Sediment layers within the cave floor showed clear, undisturbed stratification, essentially a natural timeline of deposits built up gradually before the entrance was sealed, allowing researchers to potentially date different layers and reconstruct a sequence of events or occupation phases with far greater precision than sites disturbed by later human activity or environmental exposure typically allow. Among the findings that generated the most significant scientific attention were animal remains showing signs of processing and use by early humans or closely related hominid populations. Evidence including cut marks on bones consistent with butchering activity using stone tools, alongside charred material, suggesting controlled fire use within the cave chamber itself. What made these particular findings genuinely significant, rather than simply representing another confirmation of already well understood early human behavior, was the specific combination of species remains found together, alongside their precise stratigraphic position within the sealed sediment layers, information that allows researchers to build a far more precise timeline of exactly which human or hominid populations were present, what they were hunting and processing, and how their behavior potentially changed over the specific period represented by the cave's occupation before it became sealed. Genetic analysis of any recoverable organic material, where DNA preservation conditions allow it, represents one of the most valuable potential outcomes of sealed cave discoveries like this, since the stable, protected conditions within a long sealed chamber can sometimes allow ancient DNA to survive in usable condition far longer than it typically would in more exposed environments. Successful ancient DNA extraction from sealed cave sites elsewhere has previously provided crucial evidence regarding interbreeding between different early human populations, including groundbreaking research establishing genetic evidence of interbreeding between Homo sapiens, Neanderthals, and the more recently identified Denisovan population. Discoveries that fundamentally reshaped scientific understanding of how different early human species interacted, competed, and in some cases interbred throughout the later stages of human evolutionary history. Beyond direct human or hominid activity evidence, sealed cave environments like this one also frequently preserve crucial paleoclimate and paleoenvironmental data, information about ancient climate conditions, vegetation patterns, and animal populations that existed in the surrounding region at the specific time the cave became sealed. Mineral deposits, particularly stalagmites and stalactites that continued forming even after the cave's entrance was sealed, can be analyzed using isotope geochemistry techniques to reconstruct detailed climate records covering the tens of thousands of years since sealing occurred, essentially providing scientists with a natural, continuously recording climate archive that complements and helps calibrate other paleoclimate data sources like ice cores and ocean sediment records used elsewhere in climate science research. The genuine scientific significance of discoveries like this extends well beyond simply satisfying curiosity about a single isolated site. Each newly discovered sealed cave environment provides researchers with an increasingly rare opportunity to study a genuinely undisturbed snapshot of prehistoric life, environment, and behavior, information that helps refine and sometimes fundamentally challenges existing models of human evolutionary history, migration patterns, and behavioral development. Given how relatively rare, genuinely undisturbed sealed cave sites are, each new discovery of this kind represents a meaningful addition to a still incomplete, continuously evolving scientific picture of how early human and hominid populations actually lived, adapted, and behaved across the vast, poorly documented span of prehistoric human history. Ongoing research at sealed cave sites like this one typically continues for years after initial discovery, as researchers carefully catalog, date, and analyze the full range of material recovered, often revealing additional significant findings well after the initial excitement surrounding. The discovery has faded from public attention. This methodical, painstaking scientific process, rather than any single dramatic reveal, represents how genuine archaeological understanding actually advances, gradually building an increasingly detailed and accurate picture of humanity's deep prehistoric past through the careful, sustained study of exactly the kind of rare, remarkably preserved sites that sealed cave systems provide. If you found this exploration of sealed cave discoveries and what they reveal about our prehistoric past interesting, let us know in the comments what ancient mystery you'd like us to explore next, and subscribe for more deep dives into archaeology, human evolution, and the ongoing scientific work continuing to reshape our understanding of the human story.